Hello, everyone, and welcome to the WFEO Young Engineers Future Leaders Committee webinar series titled Engineering the Future, Resilience and Sustainability for Young Engineers. My name is Firas Diab. I am the chair of the Young Engineers Future Leaders Committee at the World Federation of Engineering Organizations, and I am the moderator of today's webinar. This webinar series will explore the various aspects of engineering and the indispensable role it has in resilient and sustainable societies. The COVID-19 pandemic has exposed inequalities and vulnerabilities across social, economic, and environmental spheres, ensuring a rapid recovery while laying down the foundation of more resilient systems is a precondition to achieving the 2030 agenda, including the Sustainable Development Goals. This series of webinars seek to highlight the role of engineering design and systems-based approaches in risks identification, mitigation and reduction, as well as recovery. It will highlight the key challenges to address and opportunities for better engineering systems across multiple sectors. These sessions will also discuss how different levels, technology, finance, governance, collective action can promote a shift towards more sustainable social, economic, and environmental systems. In times of uncertainty, but with a clear compass towards social and environmental targets outlined in the SDGs, the systems that surround us need to better absorb future shocks and chart a transformative path to achieve sustainable and inclusive future. For our webinar today, I would like everyone from the attendees to share with your own followers and on Twitter the following hashtags: WFEO, Engineering the Future, and hashtag Young Engineers. You can also tag us on at WFEO. Definitely, we would really like to hear from you, so ask your questions, share comments, even challenge our speakers, and you can use the question and answer panel. At this point, I want to introduce our featured speaker so we can get into our content. Our first speaker is Prof. Gong. He is the president of the World Federation of Engineering Organizations. For people who don't know Prof. Gong, he's an electronics engineer with an expertise in information, communication technology, and more than 30 years experience in engineering education, research, and management. Today, he's going to talk about the responsibility of young engineers in achieving the SDGs. Welcome, Gong. Floor is yours.
Hello, thank you. Thank you. Thank you, everyone. Good day. And on behalf of the World Federation of Engineering Engineering Organizations, I extend my warm welcome to all of you to attend this webinar organized by the WFEO Committee for Young Engineers and Future Leaders. Now, please let me share with you some slides to make an introductory speech about what is WFEO and our mission to engineering for a sustainable future. That's a topic I would like to use for today's webinar. So WFEO consisting of some 100 national engineering organizations and more than 10 regional or continental engineering organizations. That makes the Federation is the world's largest engineering family. And under the auspice of the UNESCO, WFEO is founded in 1968. And now we have the official status with many UN bodies, such as UN ECOSOC, UNIDO, ITU, ISO, UNEP, UNDP, and so on and so forth. And in UN system, WFEO is the coordinator together with the International Science Council as a major group of the stakeholders for scientific technological community. A very important role of WFEO is to make voice of engineering in the world, especially in UN system. Here, the pictures you see the last year in the UN Scientific Technological Innovation Forum held in UN headquarters in New York. And here is our representative have intervened in the high-level political forum also last year in New York. And these picture shows this year, because of the pandemic, we have made an online side event just 2 weeks ago at the high-level political forum for sustainable development, which is partly offline held in New York. So here you see the role of WFEO in the UNESCO engineering report. And here, these picture shows the editorial committee, and these people with the red circle is from WFEO. You see how important WFEO in this editorial board. And here I show you a joint declaration we have made with UNESCO together last year, the year before last year, to celebrate the 50 years anniversary of the World Federation. And here is another example supported by UNESCO. That is the UNESCO WFEO African Engineering Week. Every year in September, in different African countries, we will have an African week. And during this week, not only a high-level forum will be held, and also the training courses to the young future engineers will be carried out during this week. And a very important work for WFEO is to promote the engineering education. Since last year, WFEO worked with IEA, IFES, ICEE. IEA is an umbrella organization for so-called Washington Accord, Dublin Accord, Sydney Accord for higher engineering education. And we work with them together, supported by UNESCO, to review the current benchmark standard. We call it graduate attributes and professional competencies. We review these standards and made a proposal to update it to reflect the requirement of the 2030 Sustainable Development Goals and the fourth industrial revolution. Now, within the WFEO organization, we are making the consultation to the new proposals. So, why we talk about sustainable development? All of us know, since the Industrial Revolution, we have economic development, we have social development, we have population growth. But these development also cause some results. There are two negative results. One, we call it energy and resource consumption exploding. And another exploding is emission of the various pollutions, especially the carbon dioxide. And these two exploding causes the at least four results, among many others: the shortage of resources, the environmental pollution, the ecological destruction, and climate change. And this makes this world and the life on this planet unsustainable. Facing this climate change problem, we have some striking numbers. Here you see there are 6 million children die before the age of 5. And that 40% of population worldwide does not have access to sanitation. 29% of the global population lacks safety drinking water supplies. 50% of the world are not digitally connected. And the climate impacts would push 100 million people into poverty by 2030, and many, many others. Facing these challenges, the world leaders come together in the year 2015 to celebrate the 70 years of the United Nations. At this General Assembly, a very important resolution has been made. That is a resolution adopted by the General Assembly on the 25th September 2015. The adopted resolution is agenda. The name of the agenda is Transforming Our World, the 2030 Agenda for Sustainable Development. In this agenda, there are 17 goals we call Sustainable Development Goals has proposed we have to achieve these goals by the year 2030. And these 17 sustainable goals and 169 targets under these goals were announced at that General Assembly of the UN, demonstrate the scale and ambition of this new universal agenda. That's the agenda agreed by the leaders of more than 190 countries of the world. And these goals seek to realize the human rights of all and to achieve gender equality and the empowerment of all women and girls. That means the overarching objective of this Sustainable Development Agenda with 17 goals is leave no one behind. And these goals are integrated and indivisible and balance the three dimensions of sustainable development. The three dimensions is the economic, social, and environmental. These 17 goals are not just for economic development or just for social development or environmental protection. It's the balance of these three dimensions. We can understand the goals and targets in another way. It is stated in the UN document of the 2030 Agenda. It is that the goals and targets will simulate actions over the next 15 years in areas of critical importance for humanity and the planet. So here is the interaction between the SDGs. Here you see the 6 goals: no poverty, zero hunger, good health, education, gender equality, clean water and sanitation. These goals improving the human well-being. And there are some goals relating to the planet: climate change, life below water, life on the land, the biodiversity. And between the human well-being and the planet environment, there's a tension. If we ignore the limitation of the planet, we may get human well-being for this generation or next generation, but we cannot sustain them. But how to balance the human well-being and the planet limitation? That comes the goals linking, we call it the linking goals. That is the economic growth, the energy, the clean energy, the decent works, and the industrial innovation and infrastructure, the balance of the economic development, the resilient cities, sustainable cities, resilient the human community, the responsible consumption and production, the peace, justice, and strong institutions, and the partnership of the globe. So consider these linking goals. The purpose of them is to maximize the human welfare over environmental cost. So to maximize this ratio, to realize this maximization, science is needed, technology is needed, engineering is needed. Just as said by the Secretary General of the United Nations, Mr. Guterres himself is an engineer. In his letter to WFEO in our conference, Global Engineering Conference 2 years ago to celebrate the 50 years anniversary of the World Federation of Engineering Organizations, he said, we strive to achieve the 17 Sustainable Development Goals, the world's blueprint for building a future of peace and prosperity for all on a healthy planet. Every one of the goals requires solution rooted in science, technology, and engineering. And it is also said in the statement of the UN solution of the 2030 agenda. It is that we can be the first generation to succeed in ending poverty, just as we may be the last to have a chance of saving the planet. The world will be a better place in 2030 if we succeed in our objective. However, these objectives has been damaged by this crisis of COVID-19. In the recent report of the Sustainable Development globally, which was released 2 weeks ago during the high-level political forum, the Secretary General of the UN, Mr. Guterres said, while this crisis is impairing progress towards the Sustainable Development Goals, it also makes their achievement all the more urgent and necessary. Moving forward, it is necessary that regional gains are protected as much as possible, and a truly transformative recovery from COVID-19 is pursued. One that reduces risk to future crises and bring much closer the inclusive and sustainable development required to meet the goal of the 2030 Agenda and the Paris Agreement on climate change. It will require a surge in international cooperation and multilateralism. So engineering is a key to achieve the Sustainable Development Goals. Engineers, especially young engineers, are shouldering the responsibility to transform our world to sustainability by achieving the 17 goals. Ladies and gentlemen, let's work together to build back better from the COVID-19 crisis and accelerate the actions of delivering Sustainable Development Goals. At this point, I stop my speech. Thank you for your attention.
Thank you. Thank you, Gonki. It's always a pleasure to hear you and to hear this presentation, which was very fruitful in discussing the things related to the SDGs and the overall work of the WFEO. Now, if you allow me, I want to introduce our featured speaker, Mr. Matthew Baldwin. Mr. Matthew is the first European coordinator for road safety and was appointed in October 2018. He combines his new role with his existing work as the DG Move Deputy Director General, particularly on sustainable mobility and connected, automated, and autonomous mobility. Here, today, he shares his experience in sustainable transport and safe roads and speaks about the current challenges and how young engineers can contribute to the development of sustainable and resilient infrastructure. I would like to welcome you, Mr. Baldwin, and I thank your presence. I know that you're always on a busy schedule. It's our pleasure to have you as a guest in one of the activities of the Young Engineers Future Leaders Committees. And definitely, we will be looking to hear you and to have your recommendations on the issues of transport, mobility, sustainability, and what would you say today for young engineers? The floor is yours.
Thank you very much, Firas, and thanks for having me on this great webinar. Yes, my name is Matthew Baldwin. I work at this strange institution called the European Commission in Brussels, which may seem very foreign to many of you, and I'm happy to talk about that too. Great to see so many people joining from across the world. I see Colin on from Brisbane, where it's getting awfully late. Hello, Isaac, Tuntuf and Joseph, Yassin, all of you in Africa, Lebanon, friends from Europe, Austria, the Netherlands, India. So it's great. It's a truly global forum, and it's great to be with you today. I'm also delighted. I think I'm the only one who's not an engineer on this thing, so you can kick me off now if you like. But I still want to talk a lot about the role of engineering, and I want to talk about one subject in particular, which is road safety, because of the great role that engineering has played in saving lives in the past, present, and future, and not just in the obvious things, but I'll talk about those two, about vehicle design and road design. But I also want to challenge you a little bit and to talk about the limits to a pure engineering approach. You guys have got to get out of your workshops, out of your labs, away from your design tables, and you have to work with the rest of humanity if you're going to deliver on some of the great goals that Gong Yi has just set out for you so well, the Sustainable Development Goals. Let me begin with some horrible numbers. You know, you guys do numbers, but these are going to knock you down. Number of road deaths every year in the world, 1.3 million a year. We have 23,000 a year just in the European Union. But that global number, that's more people, I think, than are going to die this year from COVID-19. Road deaths are the biggest killer of young people aged 18 to 30. Not tuberculosis, not diarrhea, not malaria, humble road crashes. So why don't we hear more about that number? Why do we accept this ludicrous number of 1.3 million people dying a year on our roads? We don't accept it anymore in the air. That number of people dying on the roads is the equivalent of 10 fully laden jumbo jets crashing every day. It's a busload of people every day in just the European Union. So if we don't accept those deaths in the air, why do we accept them on our roads? And why do we accept this huge cost to our society? The cost of road crashes is between 1% and 2% of European GDP. So I want to talk a bit about this. The old view of why we accept this is it's just something that happens. It's the price we pay for mobility. Everyone of my generation, and I'm an old guy, knows someone who died in a car crash. And you will still hear people say, there's nothing we can do about deaths on the road because 93% of fatal crashes were caused by human error, by humans making mistakes. So until we can find a way of changing human beings, there's nothing we can do. You will hear a lot of people still talk about the role of education and enforcement in making our roads safe. And those are important, training children, training young people to be more safe on the roads. But again, they're predicated on changing the way people are, stopping people drinking and driving, stopping people using drugs on the road. All of these things are important, but they're not going to solve the problem. And I want today to describe to you an engineering-driven, revolutionary concept. And it's a very simple concept. And it's called the safe system. And it's predicated on accepting that human beings are who they are. I make mistakes the whole time. I drop my keys 3 times a day. I bump into my office furniture. These mistakes don't kill me. But if I make a mistake on the road, I can kill myself, or worse, I can kill someone else. I can kill their family. So if you turn the question around, and this is relevant to engineering, bear with me. If you turn this question around, if we can't stop people making mistakes, how can we stop people dying from their or other people's mistakes? Well, then I hear you say, well, I don't, but I can imagine you saying, can we eliminate through technology road crashes altogether? Well, perhaps one day we'll be able to do that. We're making big progress in connected and automated driving, for example. But for at least the next 20 or 30 years, we're not going to have fully automated cars driving everywhere across the world. And if you don't have everyone in an automated car, or even most people driving automated cars, you're going to have a mixture. That could be even tougher. Imagine the first car's fully automated on the road. It's the rich businessman in the back of the car, and it probably will be a rich businessman. And he's going along and the car's driving super safely, and then goes past him in the fast lane, a big old VW bus, belching smoke, playing loud rock music. And he's thinking, what the hell? This isn't safe. This isn't the safe system. Problem is, we got too many things mixed up. So I don't think we can count on technology, but we still need the engineers. I'm coming to you in a moment. Keep thinking through this revolution. If we can't prevent crashes happening, can we mitigate the effects? Let me give you an example. Most of the injuries that occur to people on Swedish roads in winter are to pedestrians, walking on their own, slipping on an icy pavement or sidewalk. And if you slip and fall on an icy road, and we've all done it, you can hurt yourself. You can sprain your wrist, you can bruise your head, you can maybe break your hip, but you're not gonna die from it, except in really exceptional circumstances. And this is what the safe system says. There will be mistakes, there will be crashes, there will be injuries, but we need to focus all of our efforts, all of society's efforts, at preventing those crashes, killing or seriously injuring people. And let me give you another example from Sweden as to how this is important, of a road junction. And it was a dangerous road junction of a little road coming on from the side to a big fast road. And they noticed there are a lot of crashes and a lot of people dying. So they put in some traffic lights, and then they examined the results. And after 1 year, they had some very strange results. They couldn't figure it out. The number of crashes had reduced a lot because the traffic lights, most of the time, people stopped. But the crashes that happened, the number of deaths were way up. Because guess what? People who go through the traffic lights, they go through them at speed, and the crashes that happened were more serious. They changed the traffic lights and they put in a roundabout. What happened? 5 years later, the number of crashes had gone up. The number of people who died, 0. This is the safe system at work. We find a system which prevents people dying from the mistakes that people make. So let me take you through those different elements of the safe system, and you'll see immediately how engineering will come to make a difference. First item on my list, it's the vehicle you're driving. And thank you, engineers, for the brilliance you have brought to modern construction. Engineering the cage of protection, the crumple zone in the front end of the car, the headrest behind. Cars today are infinitely safer than they were even 10 years ago, thanks to the brilliance of vehicle engineers across the world. But it took more than the engineers to get these inventions into our cars. It took standards, it took laws, it took regulation. We're immensely proud of what we've achieved in the European Union through successive waves of vehicle legislation, driven, in fact, by our single market. We said, if you want to sell a car, it's got to have similar safe standards across the European Union. If you're buying a car in Portugal that's made in Germany, you want to know it's made according to the same safe standards. And so through successive waves of vehicle legislation, driven by the single market, and amplified through the UN system, mainly through the UN ECE, we've built safe car regulation into the global car market. And that's still the biggest single factor in what we've achieved in the European Union in bringing down our death rate from more than 200 per million of the population down to just around 50. So we brought it down by 4 times over just 50 years. Second item on your list, protective equipment. Your car crashes. However well built it is, however modern it is, you are going to die if you continue moving at 120 kilometers per hour and the car stops. It's about the application of kinetic energy, about which you all know a lot more than I do. So you need passive restraints, you need seat belts, you need airbags. But what's the use of a seat belt if no one uses it? You need regulation, you need mandatory installation, you need mandatory wearing of those seat belts. Third item on your list, if your car is going to crash, the infrastructure. It could be a beautiful modern car and you're wearing your seatbelt, but if you go off the road and over a cliff, you're going to die. So you need modern, safe roads. You need side rails. You need center rails. You need rules to force governments to spend money to employ the engineers, the road engineers, to make those roads safe. Not just to build the biggest, the fastest, the widest, the snazziest roads we can build, but the roads that protect, roads that forgive, roads that are built for people. And again, at the European level, we're proud of the legislation we've recently passed, the Road Infrastructure Safety Management Directive, which requires our member states to take safety into account on their national roads. And something I'm going to talk about more in a minute, takes the vulnerable road users also into account in designing those roads. Fourth item on my list, I will stop, it's not a very long list, but it's got a few more points. The fourth item on my list is speed. You could be in the safest car on the safest road, wearing your safest safety belt, but if you're going 200 kilometers an hour, you will die. In cities, if your car strikes a pedestrian at 30 kilometers an hour, it's about 20 miles per hour for those who are using the old money, that pedestrian has a 90% chance of surviving, 90. If your car hits the pedestrian at 60 kilometers an hour, it's around about 40 miles per hour, a bit under. And I'm afraid that's the speed that most cars are driven at in modern cities. The chances of the pedestrian surviving go down to just 10%. Why we don't have mandatory 30-kilometer-hour speed limits in our cities across the world, globally, with just that one statistic, I fail to understand. But if you look at the people who are dying in our cities, 70% of them are not in cars. They're walkers, they're cyclists, they're motorcyclists, they're people without the protective cage of a car. They're what we call vulnerable road users, although some people call them the valuable road users. Again, and I'll say more about that in a moment. And in the European Union, 70% of us are already living in cities. That'll be 80% by 2050. So we need to think about urban safety as a key new dimension. And again, that fits perfectly into the SDGs that you heard Professor Gong just speak about. The fifth item on my list is post-crash care. 65% of victims die at the scene of the crash or within the first 4 hours after the crash. So getting effective post-crash trauma care, ensuring maybe it's just effective transportation to the hospital that can tackle the injuries, can make all the difference between a terrible crash that kills you and a terrible crash which you ultimately survive. And last but not least, and I'm very glad to hear you talk about this, it's about governance. We need engineers involved in governance. This is a very complex list of things to do, if you think about it from the perspective of a government. Vehicle rules, rules on roads, speed limits, seat belts, healthcare. In the EU, some of these things we can legislate at the level of the European Union. Some of them are for national rules, and some of them are just local. So we need to ensure that each country, each member state has a lead agency, preferably with some engineers who understand these principles, responsible for road safety, and that we work together to ensure local, national, regional, global coordination, and that we set some targets. I'm delighted to hear Professor Gong talk about the SDG targets. We have SDG targets for road safety to reduce deaths and injuries by 50% over the next decade. And we want to work with you, the best engineers, to achieve those targets. So if I've managed to interest you as young engineers in this great social global challenge, it's because it's not just about finding the perfect engineering solution, the perfect car, the perfect road. It's about that interface with governments, with industry, with NGOs, with people. The safe system needs to work with people as they are. Some people say, it's ridiculous, people are stupid. Stupid people just step off the curb and step into the path of my car. Well, I want a system which saves the stupid people. Stepping off the curb might be a stupid thing to do, but death is not the appropriate penalty for that action. And we can and we should make people safe for it. And the challenge, when you think about it globally, goes beyond safety. It's about sustainability in the truest sense of the word. Indeed, how we can work together to save this planet which we live on. I mentioned, or you kindly mentioned right at the start, that I'm responsible for road safety and for sustainable mobility. What do these two communities have in common? They're completely different, aren't they? Road safety is a classic engineering subject, male, balding people like me, and sustainable mobility is for hippies with colored hair and multiple body piercings. People who want to ban the car, right? Well, let's see if we can get these two communities to work a bit better together. Just take one example. If we can reduce the use of private carbon-fueled cars in our cities, look at what we can achieve. We can make our cities safer. We can make the air quality better. We can reduce CO2 emissions. We can reduce congestion. We can reduce noise. We can protect our cities against the habitat damage. We can make our cities more livable. We can make our cities more lovable. And we can do these things. The COVID crisis shows the capacity of public acceptance of rules. We've accepted lockdowns right across Europe, right across the world, in order to save lives. Let's take the necessary actions that we need to take for safety and sustainability. It's never been a tougher time for our planet, but I've never been more optimistic that we can do more together. Thanks for your attention. Look forward to your discussion, and I want to hear your views now. So let's get to the chat. Thank you very much.
Thank you very much, Mr. Baldwin. Indeed, it's a very great presentation. We were happy to hear you, and definitely many people all over the globe, engineers and other young people and people attending this webinar, we're happy to listen to you. The thing is that, you know, after your presentation and the presentation of Gonki, I would like directly to go to the Q&A section. And here, you know, definitely we're getting many questions on the chat box, and we're getting some other questions on the Google Docs document. But I would like to start here by mentioning, which is one question which would be might be of an interest to many. Do you think that what sort of specific technical skills young engineers should develop in order to develop or to deliver a sustainable transport infrastructure? What advices do you give in this regard, yani, for young engineers?
You're asking me?
Yes.
My goodness, you're asking a non-engineer to tell engineers what technical skills they need.
This would be more interesting. You're seeing it from outside the engineering perspective.
Well, I'll tell you, since I've been working on transport, I've worked with aviation engineers of all kinds. I've worked with mechanical engineers, electrical engineers. I mean, there are more engineers than there are words in the language. And I think that's because society needs to reflect engineering, and engineering needs to reflect society. just to give you an example, the people now working on some of the connected and automated car systems are psychologists who know how to work with engineers. Why? Because they're trying to assess the point at which a human being is distracted or asleep or drunk or unable to exercise control over the car. So engineers, we need engineers who understand governments, engineers who understand psychology, who understand the human being. I urge you to get out of your corner. We all have to get out of our silos, and the more skills you have which reach across and mean that you can do more than design the perfect technical solution, the more useful you'll be to society. That's my advice. But you might also want to speak to someone who really understands engineering, which isn't me.
Firas, you're muted. Firas, we could not hear you.
Are you hearing me now?
No. Good.
Yeah, I'm checking this Google Doc and I'm seeing like plenty of questions. One of the questions which comes from Kenya, I have a question from Canada, from Australia, from the United Kingdom. One of the questions, maybe Gong, you can attend to this question. One of our colleagues from the United Kingdom is asking, do you believe that young engineers and graduates are capable of implementing sustainable practices, or is it solely up to the big firms that control the industries? What do you think, Gong, on this?
Actually, when we talk about sustainable development, it is a systematic engineering project worldwide. We should work together from multiple disciplines. As a single engineer, I think something is important besides of he or she have a well-mastered his or her professional knowledge and skills. He and she should know more about sustainability. What does sustainability mean to his or her profession? That is very important. For today's engineering education, this part is a shortage. We lack of the knowledge and skills of the sustainability linked to every engineering disciplines. We may have a general course talk about sustainable development, but we have to link this with his or her own profession skills. That's the first. Second thing I'd like to mention is that today's world is going to a new industrial revolution. And this revolution, we call it the data-driven revolution. So today's engineer should have the capability to manage big data. I think that is also very important. On the one side, we have to know how to access to data, how to process the data, how to judge the quality of the data and use this data. On the other side, we have to know the regulations of using those data, how to keep the privacy, keep the security, and so on and so forth.
Exactly.
And that is also very important for today's engineer. But in today's engineering education curriculum, this knowledge and skill is not taught enough. And thirdly, I think it's very important is to have the capability of cross-disciplinary cooperation. I think that is very important because today's project, we face engineering project, we're facing very complex problem. We have to work in team with different disciplines, and we need some training for this kind of cross-disciplinary collaboration, even cross-cultural collaboration. And that we should reinforce these kinds of training in the current engineering education. And among many others, engineering ethics is fatally important, but that not have been educated sufficiently. So we have to pay attention to these points. So that's my answer.
Thank you, Gong.
Could I jump in on this one? Because it's a great question.
Sure.
I completely agree with Professor Gong, but I want to just add a couple of things to it. I mean, yes, absolutely, engineers should be aware of the twin revolutions, sustainability and digitalization. And indeed, I just want to flag, we'll be coming with a new EU transport strategy for both those things later this year. But what you say in your beautiful analysis, Professor, about data, is you also have to understand the politics of it. Technology means we can now gather infinite amounts of data. And the question is, what are the relevant bits and how we can put that to good road safety use? I'm militating now to try to have an EU-wide, the modern, I just can't make my words out, a common EU approach to analyzing crashes, fatal crashes, using all the data that is now generated by the infrastructure and by the vehicles. But how do we use that data? What are the rules that govern it? What are the politics surrounding it? And what is the use of gigabytes of data if we can't break it down and turn that into good policy uses? And the other thing I would just add, one thing I would add to Professor Gong is when you look at all the different areas where we need to address these twin revolutions, we need to address sustainability by using digitalization. My real advice is follow your passion. If you find something that you care about, you will be infinitely better than doing something you feel ought to be done. I am now in my last decade of work. I've found the thing that I truly believe in, and it gets me up every morning and it keeps me in the office until late at night because I profoundly believe, I think possibly for the first time, that I'm doing something that might just make a difference. So that's, I mean, it's a terrible cliche, but I really mean it. It's when you're starting out, follow something you really care about.
Thank you. Thank you, Matthew. I have got something interesting here in the chat box. Some attending the webinar is asking or just giving his remark that most governments would world over do not involve professional engineers in governance issues. Engineers are only approached when things go wrong along the way in terms of poor quality of structures. This is something sad, but sometimes it's true. I would like just to give ask this common question. I get it from many people. Maybe in the era of COVID-19 or the time that we're living nowadays, what do you think? What are the range of uncertainties many young people now face globally as they negotiate the daily mobility? Definitely there are many uncertainties that we're facing. Can you have a talk on this, Mr. Baldwin? You're muted.
Sorry, if you could just repeat the last point you made because your line broke up.
That there are certain range of uncertainties many young people are facing, definitely when they are negotiating the daily mobility. Can we have your idea about these uncertainties, that we're living in the time of COVID-19 and some other difficulties we're facing?
Yeah, two really good points. On the first one about, governments only involve engineers when things go wrong and then they tell them to fix it. I totally get that. I think scientists generally have the same feeling. We're having everyone, of course, in COVID-19, there's a great debate, isn't there, about the role of science in political decision-making. And I think to challenge you all a little bit, part of that is you as engineers and scientists generally, you have to make it easier for governments to follow your advice. So you have to think about not always giving the perfect, infinitely expensive, complex solution. Politicians and governments sometimes need what I call a quick and dirty fix to a problem. I mean, I'm going to look at any way at which I can find a way to reduce road deaths. I'm not interested in a perfect utopian engineering vision. Come with something which works, which is cost effective, which can improve the lot of the greatest number of people as quickly as possible. on this, the second point of what you raised about the uncertainties of life, well, I think mobility is one of the great examples of how we could end up in a massively suboptimal solution post-COVID. Just to quote a poll that was taken here in Belgium by the national newspaper Le Soir, 46% of people are now scared to take public transport. 40% of people want to use their bikes more and to walk more, but nearly 2/3 of the people say that they want to see better infrastructure so they feel safe and confident before they get on their bikes or they walk to work. 20% of people want to use their cars less. But if you put all that together, if you have more people on their bikes and more cars because people are scared to use public transport, people aren't going to stay on their bikes for very long. So we really need to find quick solutions to develop that better bike infrastructure, to make people feel safer, to make people feel safe to go back in public transport. We rapidly need brilliant organizational engineering solutions for this. How to make physical distancing work, adjusting the schedules. Maybe we need to stagger the way we go to work. We don't all go to work at the same time or go to school at the same time. So in other words, engineers need to come in on processes as well as on products. And they need to help us find solutions which, again, deliver sustainable and safe solutions. We could end up with an old normal, a new normal, which is worse than the old normal, if we're not careful.
Thank you. Thank you, Matthew. I guess my colleague, Melda, she played a great role in introducing you to the WFEO Young Engineers and Future Leaders Committee. I believe that Melda have one or two questions, maybe to yourself or to Prof. Gong. Melda, can we hear your question?
Yes, let me know if you cannot hear me. Thank you, Firas. It was indeed very good presentations, and it's very good to see a good feedback and many questions we're getting. But when Mr. Baldwin was speaking about the terrible numbers of accidents, and there are so many initiatives and regulations to which promotes the safety of roads. So what are the key factors, and why this is failing? Why there are still such a high numbers of roads accidents? And I also contribute to the questions from Dr. Mashna from Kenya, and he's also asking about the road safety. But could you identify the most important factor contributing to accidents: the drivers, road users, road design, road conditions, powerful engines? Or maybe that's the questions of regulations.
All right. Great, thank you both, both Milda and Dr. Meshna from Kenya. I don't know, Milda, whether you are going to be popular for having introduced me to the WFEO. I suspect you're going to be very unpopular because people say, "Why did you bring that guy on? He was a disaster."
We get you very popular.
Because you're a friend of mine, Milda, I'm gonna take you on. The problem we have on road safety is of one word you used, which is accidents. Accidents are just things that happen, right? They're things that God decided to happen. I was just driving along and I had an accident. It was just something that happened. I refuse to use or accept the word. I talk about crashes, because crashes and deaths from crashes are things that we know how to prevent. And so this brings me to the same question that you and Dr. Meshna asked, which is, what's the most important factor in causing the crash? To be very honest with you, I'm not so interested in what causes the crash. What I'm interested in is what causes the death or the serious injury from the crash. Again, the safe system says, maybe we accept some crashes, some slips on the icy road in Sweden, as long as people are not dying from those things. When you come to look at what causes the fatality, it gets really complex. And I like to use the example taught by the great Professor Soames Job from Australia, who illustrates this by saying, in a nice simple way, how do you make salt? What's that got to do with road safety, you ask? Well, The point about how do you make salt, and all good scientists will immediately say, well, you need sodium, and you need chlorine, and you need oxygen, and you need a heat source. Without any one of those 4 elements, you can't make salt. But it's kind of pointless to say which is the most important element. Is it the sodium? Is it the chlorine? Because again, if any one of those things is not present, you don't have salt. The same thing with a fatal road crash. You're going to have someone making a mistake, that's for sure. You're probably going to have a car which has got defective tires. Maybe the infrastructure is not very safe, so when the car goes off the road, it runs into a roadside stall. You don't have a rule which says the car shouldn't be driving too fast. You need, usually for someone to die, you're going to have a cocktail of reasons. And that's why road safety is so difficult and it's so fascinating. And the role of the engineer is as much to collect together the things we need to do to prevent that death from happening. That's what the safe system's about. It's really a revolution. And if you're interested in it, drop me an email, follow me on Twitter, because it's what I talk about all the time. And it'll add to the list of people I'm boring to death about it. So thank you for your forbearance.
Thank you, Matthew, very much. You know, the topics are really interesting, and you know, we're coming to conclude this webinar. We have set the time for 1 hour. I would like to just from Prof. Gong, if in 30 seconds or 1 minute, if what can you say finally for young engineers in terms of you know, working for achieving the SDG goals or the 2030 agenda?
Very quickly, I would like to repeat what has said by Matthew. Passion. I think the first thing is passion. Passion for working for a sustainable future. And then to study. We have to study. And third is cooperation. I think passion, learn, cooperation is most important for young engineers. Thank you.
Thank you. Matthew, Mr. Baldwin, what would you say for the, you know, for engineers and any other young people who are dealing with the issues of sustainable roads or sustainable infrastructure? What message would you like to leave today?
Well, I think what Gong just gave you was a great list, and I fully endorse that. It's not enough just to be passionate about something. You've got to work, and you've got to work. Look, our generation has screwed up. Okay, our generation has left you this mess. As I descend into my old age, I thank you for your efforts to fix it. All I ask, again, is Gong, is you bring your passion and you bring your work to bear, and I'll try and live as cheaply as possible so I don't cost you too much in terms of taxes. But just, and joking aside, these two things, sustainable and safety, they're two sides of the same coin. That's why safety belongs in the Sustainable Development Goals. And at its most basic level, it's about making sure that the breadwinner from the African family is safe and still able to go to work and make a living to support her or his family. I've loved this webinar. Thank you for listening to me, and I hope to convince you to come and work in one of these great areas.
Yeah, thank you. You know, now we're coming for the closure of this webinar. This will be one of a series of webinars, will be under the title of Engineering the Future. This is all the time we have for our webinar today. We're looking forward for future webinars, and I want to make sure for everyone that this webinar is recorded and will be posted later at the Young Engineer Future Leaders Committee page at the WFEO, and will be shared for everyone, for people who missed it and for people who simply want to go over it again. Finally, I would like to extend my thanks again for the speakers today, Mr. Matthew Baldwin, and for the President of the World Federation of Engineering Organizations, Dr. Gong. Also, I would like to extend my deepest regards and thankfulness for all the Executive Board and the Executive Council of the WFEO, and for our supporting team, and the Secretariat in Paris. Special thanks goes for the people who are helping in this committee, and basically Milda, who contributed positively for this webinar, and Donovan as well. And definitely we're looking for future webinars which will be focused and like giving positive messages for young engineers all over the globe. On behalf of the WFEO Young Engineers Future Leaders Committee, I would like to thank you all for participation, and we'll make sure that all the questions will be like filtered and sent for the speakers, and we'll definitely be sending a follow-up email. Thank you very much, and hello for everyone.
Hello,
bye-bye.
Hello. Thank you. Bye-bye. Bye-bye. Bye-bye.